Hello, everyone. My name is Jamie Galloway, and I'll be presenting my Biology 363 course level interactive case study 6, which is over cancer treatment and understanding the components of CHOP drugs, which are multiple different drugs that are used to take on the treatment of cancer utilizing the chemotherapy method. To start off, it's important to understand tubulin, as we'll be talking about it multiple times throughout this presentation. Tubulin is a vital protein in cells that essentially provides the skeletal system for cells. It gives a good structure to the cell. This vital protein in cells is able to provide a multitude of different tasks, including providing structural support for the cells, allowing a pathway for transport, and it is also able to force generation in the process of cell division. Tubulin is a protein that is vital for cell division to occur within the cells. Without it, cells would not be able to undergo cell division properly. So how is tubulin used in cell division and why is it important? Since the importance of this protein has previously been expressed prior to this slide, it is important to understand how it works on a molecular level during the process of cell division. Tubulin works in cell division by working to enable the cells to undergo mitosis. Tubulin also works by polymerizing to form microtubules during the process of cell division due to it belonging to both alpha and beta families. Tubulin is necessary for cell division due to its major role in forming the microtubules. Microtubules are vital for cell division as they are an important essential component in separating the chromosomes. Oncovin. Oncovin is a drug that is heavily used in chemotherapy cancer treatment as an anti-cancer treatment drug. Oncovin is a drug that works to slow the growth of cancer. Oncovin is used in a vast list of cancer treatments. Treatments for leukemia, non-Hodgkin's lymphoma, Hodgkin's disease, neuroblastoma, brain cancer, and many other different types of cancer. Understanding how oncovin works as a chemotherapy drug and its role with tubulin. Oncovin works as a chemotherapy drug by being able to slow the progression of cancer. It is able to slow the progression of cancer by binding to the tubulin protein in the cells. As previously described, the tubulin is necessary for cell division for cells to keep dividing. Oncovin is able to attach to the microtubules or the tubulin protein in the cells, which in turn is able to lead to the cell cycle arrest, and it is not able to progress to cell division. This is important as this drug works to block the mitotic phase of cancer cells. It works to induce apoptosis due to the progression of the cells slowing. When this happens, cancer cells are not able to replicate nearly as fast as they could with no prevention on board due to the cell replication being inhibited because oncovin is binding to the tubulin protein, and so it's not able to divide and keep making more cells and keep the tumors growing. So oncovin binds to tubulin to be able to inhibit the cell division. Tubulin. This is tubulin working to help form the microtubules that are needed for the cell division. I found this image and I thought that it depicted a really nice visualization of what was going on a molecular level. And then to the right, I put an image of tubulin on a molecular level. It shows both alpha tubulin and beta tubulin as previously spoke about during this presentation, and I felt that this would be a good visual representation to that matter. And then I also wanted to include images of oncovin at work. And since oncovin can bind to the microtubules, it falls into the realm of microtubule inhibitors. And so to the left, I put an image of the binding of microtubule inhibitors like oncovin to the tubulin, and it shows a good depiction of that, of both alpha and beta tubulin. And then to the right, I put an image of oncovin or microtubule inhibitors that are inducing apoptosis and causing cell death, essentially. And then these are my references, all cited in APA format. And thank you for watching my presentation.